Today, I would like to discuss about how to obtain the mean and variance of beta distribution. A continuous random variable x is said to have beta distribution if its probability density function f of s equal to s raised to power alpha minus 1 into the bracket 1 minus x close the bracket raised to power beta minus 1 divided by beta into the bracket alpha comma beta in zero otherwise, where beta into bracket alpha comma beta equal to integral 0 to 1 s raised to power alpha minus 1 into the bracket 1 minus x raised to power beta minus 1 dx, where this equation equal to gamma subscript alpha multiplied by gamma subscript beta divided by gamma subscript alpha minus beta. Now, to obtain our expected value, let's have an equation is in a way of expected value of s raised to power k equal to integral 0 to 1 s raised to power k f of s dx, which is equal to integral 0 to 1 s raised to power k, the value of our f of x, which is s raised to power alpha minus 1 into the bracket 1 minus x all raised to power beta minus 1 divided by b into bracket alpha comma beta dx. We factorize 1 divided by beta into bracket alpha comma beta out, and out of the equation integral from 0 to 1 s raised to power k multiplied by s raised to power alpha minus 1 into the bracket 1 minus x raised to power beta minus 1 dx. This is equal to, that is, the equation integral 0 to 1 s raised to power k times s raised to power alpha minus 1 into the bracket 1 minus x raised to power beta minus 1 dx equal to b into bracket k plus alpha comma beta and divided by the one we factorize out, which is beta into bracket alpha comma beta. And according to what we have in this place, you can say that our beta into bracket k plus alpha comma beta equal to gamma subscript k plus alpha gamma subscript beta divided by gamma subscript k plus alpha plus beta. And we have already know that beta into bracket alpha comma beta equal to gamma subscript alpha gamma subscript beta divided by gamma subscript alpha plus beta. Since beta to bracket k plus alpha comma beta divided by beta into bracket alpha comma beta, this equation up gave us the second equation here. We put the value of each of them into this equation to change the division into multiplication. The denominator of beta comma alpha of beta into bracket alpha comma beta will change to this equation, which is this. And we know that this gamma subscript beta can cancel this gamma subscript beta, and we're left with gamma subscript k plus alpha divided by gamma subscript k plus alpha plus beta multiplied by gamma subscript alpha plus beta divided by gamma subscript alpha. To obtain the expected value of beta distribution, we say let our k equal to 1. And when our k equal to 1, we can see that we have expected value of x to be in form of this equation, which is gamma into bracket 1 plus alpha divided by gamma subscript 1 plus alpha plus beta multiplied by gamma subscript alpha plus beta divided by gamma subscript alpha. So we need to obtain the expected value of beta distribution. So using the method of factorial, we will begin to subtract 1 by extending the subscript of gamma in this equation out. We now take out the subscript of gamma in the first equation, which is 1 plus alpha. We now subtract 1 from it. And in the denominator also, we subtract 1 from it. When we take it out, we subtract 1 from it also. In the third equation, we left with, when 1 cancel 1, we have alpha multiplied by gamma subscript A and divided by alpha plus beta gamma subscript A plus beta, alpha plus beta. So gamma subscript alpha cancel gamma subscript alpha, and gamma subscript alpha plus beta cancel gamma subscript alpha plus beta. So therefore, the expected value of beta distribution give us alpha divided by alpha plus beta. So to obtain the variance of beta distribution, we need to find the expected value of x raised to power 2. And when we say that expected value of x raised to power 2, therefore we now say that any place we see k, we represent it with 2. And that's the reason why we have the first equation here to be equal to gamma subscript 2 plus alpha divided by gamma subscript 2 plus alpha plus beta multiplied by gamma subscript alpha plus beta divided by gamma subscript alpha. In second equation here, what we are trying to do is that we want to obtain something like the one we are multiplying it with here. And we continue to subtract 1 from the first value here until we obtain something like what is here. So that's the reason why we are subtracting 1 from the first equation here. So therefore, the first one we subtract 1 from the first equation here. We have the third equation, which is alpha plus 1 gamma subscript 1 plus alpha divided by 1 plus alpha plus beta gamma subscript 1 plus alpha plus beta multiplied by gamma subscript alpha plus beta divided by gamma subscript alpha. So in the fourth equation, we subtract 1 again from the subscript gamma, and we have a plus 1, the fourth a plus 1 we have before. We will not touch that one. Into the bracket 1 plus alpha minus 1 gamma subscript 1 plus alpha minus 1 divided by 1 plus alpha plus beta into bracket 1 plus alpha plus beta minus 1 gamma subscript 1 plus alpha plus 1 plus alpha plus beta minus 1 multiplied by gamma subscript alpha plus beta divided by gamma subscript alpha, which give us equation 5, which is alpha plus 1 into bracket alpha gamma subscript alpha divided by 1 plus alpha plus beta, close the bracket, open another bracket, alpha plus beta gamma subscript alpha plus beta times gamma subscript alpha plus beta divided by gamma subscript alpha. And when we cancel the one that can cancel each other, we have expected value of x raised to power 2 equal to alpha into bracket alpha plus 1 divided by alpha plus beta, close the bracket, open bracket, 1 plus alpha plus beta. So therefore, we know that our variance of x equal to the set value of x raised to power 2 minus into the bracket the set value of x all raised to power 2 and the expected value of s raised to power 2 equal to alpha into bracket alpha plus 1 divided by alpha plus beta, open bracket, 1 plus alpha plus beta. Now see that minus the value of expected value of x all raised to power 2, which is alpha divided by alpha plus beta. And we have the third equation, which is alpha into bracket alpha plus 1 divided by alpha plus beta, open bracket, 1 plus alpha plus beta minus alpha squared divided by alpha plus beta all squared. And when we take the LCM of both alpha plus beta into bracket 1 plus alpha plus beta and alpha plus beta all square, which gives us alpha plus beta all square divided by alpha plus beta all square, close bracket, open another bracket, 1 plus alpha plus beta. When we multiply each other, we open the bracket of this side, we have alpha raised by 3 plus alpha raised by 2 plus alpha raised by 2 beta plus alpha beta. And when we multiply, we open the bracket with alpha square here. We have with this negative, we have negative alpha square minus alpha cube minus alpha square beta divided by alpha plus beta all square into bracket 1 plus alpha plus beta. And where we cancel one that can cancel each other, we left with the variance of beta distribution, which is alpha beta divided by alpha plus beta all square into bracket 1 plus alpha plus beta plus beta, which is the variance of beta distribution. In my next video, I'll be discussing how to obtain the mean and variance of normal distribution in its simplest form. Thank you for watching. See you another time. Please don't forget to subscribe to my channel.